What page am I on? On 6. So 1.7, the chain rule. Okay. The chain rule refers to when we differentiate, let's say, the square root of 4x squared minus 3x plus 1. Meaning, there is an inner function Why am I talking about the inner function? Because this is the function that we have to evaluate first. If you give me this function, let's say f of x, and you say find f of 1, the first thing I have to do, I have to say 4 minus 3 plus 1. And then I will take the square root. So the square root is so-called the outer function. So how will I differentiate something like this? Well, I'll have to differentiate first the outer function and then the inner function. So when I differentiate the square root, remember we have the rule. The square root of x prime is 1 over 2 the square root of x. But now I don't have x. I have something else. But I still have to use this rule. So it's 1 over 2 the square root of the whole thing. But times, here I should have written times x prime. But this is 1. That's why I didn't write it. But now times the inner function prime. Can anyone give us a derivative of this function? And that's the end of the differentiation for this function. Can anyone differentiate this function for us so I can put it here? And this is it.
8x minus 3.
That's it. And this is the derivative function of the square root of 4x squared minus 3x plus 1. Here's another example. 3x squared minus 4x plus 2, everything to the 10th power. How do I differentiate this? With the same rule. What rule? The power rule. Bring 10 down, subtract 1 from the power, times prime, because it's not plain x, times the inner function prime. Times the inner function prime. Can anyone please give us the inner function prime? Sorry about that.
Be 6x minus 4.
That's it. That is it. Okay. I'd like us to look at the word problem and then practice some more. 172. To see how important this is. Okay, so we have the revenue here, we have the total cost. Let's choose one or the other. You want to look at the total revenue, you want to look at the total cost, just to illustrate the chain rule. And then we'll practice more. 59 or 60?
60.
Okay, perfect. So in 60 on 172, we have the cost function, which is 2,000 times x squared plus 2 to 1/3 plus 700. Sees the total cost in thousands of dollars of producing X airplanes. Find the rate at which total cost is changing when 20 units are produced. What are we asked to determine? The rate of change when X is 20 units. What are we asked to do? We're asked to find the rate of change of this function and evaluate it when X is 20. Can anyone tell us what we need to determine? Anybody, please, what do we need to determine? It's all the same thing. We've done the exact same thing over and over, over and over. Anyone would like to help? Please. What are we asked to determine? We're asked to find the rate of change. What do you think? Anybody, please. In all these problems, we determine the same thing. The rate of change of this function.
So we have to differentiate and then plug in 20 to get that.
Absolutely, that's all. This is in dollars. What will be the measurement unit for C prime? This is in dollars. And this is in units. What will be the measurement unit when we are done with this? And plug in 50. What will be the measurement unit?
Dollars over units.
Excellent. Good. So when I differentiate 700, this will be 0. I have to bring 1/3 in front, so then I have 2,000 over 3 times x squared plus 2. Remember, we have to subtract. What do we get when we subtract 1/3 minus 1? 1/3 minus 1 is 1/3 minus 1 is
2/3.
very good, negative 2/3 times the inner function prime. Times the inner function prime.
QX.
Very good. Don't do anything. Plug it in carefully, and then plug in 20. So I'm going to share my screen, go to the calculator, erase anything and everything that you have in there. That's not what I meant. Okay, clear, clear, please, clear. Okay, so in parentheses, 2,000 divided by 3. Parentheses again, x squared plus 2, close, the power, in parentheses, negative 2/3, close, come back down, parentheses, 2x. It's all in there. All I need is second and table and plug in 20. When I plug in 20, the rate of change is in dollars, thousands of dollars, 489. So the answer of C prime of 20 is $489,574 per unit. So when we manufacture exactly 20 and we sell exactly 20, the instantaneous rate of change of the cost function is close to $500,000 per unit. Okay. So now I would like to go back and practice some more. For example, find an equation for the tangent line to the graph of this at the point 2, 0. So we have 41 on page 171. Y equals x to the third minus 4x everything to power 10. And the point is 2, 0. I know that the equation of the tangent is y minus y1 equals the slope times x minus x1, where I have the x is 2 and y is 0, but I need to determine this when x is 2 at x equals 2. How do I determine the slope of the tangent line to the graph of this function when x is 2? What do we need to determine? I need the rate of change, so I know exactly what I need to determine. Every time I talk about the rate of change, what do we find? Always, when we find the rate of change, what are we calculating? The derivative. Very good, excellent. So we want to find the derivative, y prime. Can anyone get us started on the derivative here? I need to differentiate this. Can anyone help? Please, anybody, please.
Would it be 3x squared?
So you mean 10. You
10.
mean 10. Now x to the third minus 4x to which power?
Nine.
Very good. Times the inner function prime. Times the inner function prime. How much?
Would it now be 3x squared?
Yes, minus 4. So remember, first we apply the power rule. Something to power 10. 10, that's something to power 10 minus 1. Then times the inner function prime. Is that okay? Now I have to plug in 2. I have to find y prime when x is 2. And that is the slope I'm looking for. I will put this function in the graphing calculator as is. Do not try to simplify or do anything else. So, clear? Put the function in. 10, left parenthesis, x cubed, minus 4x, everything to power 9, and then come back down in parentheses, 3x squared, minus 4. And here I will plug in 2. Second and table, 2. Okay, very nice. Slope is 0. Wonderful. So if the slope is 0, then this is 0. So then y equals 0. This is the horizontal line. The x-axis, y equals 0. The last thing that I wanted to mention is in 1.8, higher order derivatives. Why do we need the second derivative, the third derivative, the fourth derivative? Who cares? You're going to see the applications of the second derivative very soon in chapter 3. More a higher order than, in other words, what are we going to do? We're going to have the function, we're going to find the first derivative, and then we're going to find the second derivative, and then the third, and then the fourth, if needed. Here's an example. The function is a distance. F prime will be the speed, and F double prime will be the acceleration. So this is an example in which the function, the first derivative, and the second derivative are used. That's it, just a very simple application. And that is, let me see, on 179. Okay, so let's start with 37. On 179. So we are given s of t, which is the distance, t squared minus 1/2 t plus 3. They are telling us that s is in meters and t is in seconds. Good. Find each of the following. They're asking us to find v of t, they're asking us to find a of t, and they're asking us to find both at 1. So v at 1 and a at 1. And of course the measurement unit. If the distance is measured in meters, can anyone, and is in the time in seconds, can anyone tell us what is the measurement unit of the velocity? Which is the rate of change of distance with respect to time. Distance with respect to time. And you know the measurement unit. The measurement unit for the speed, if the distance is in meters and the time is in seconds, will be
Meters per second.
of course. Thank you very much. Good. What about the acceleration? Careful. The acceleration is the rate of change of velocity with respect to time. Velocity over time. What will be the measurement unit then for the acceleration? They cannot be the same. Because this is the rate of change of this with respect to time. Meters per second, but squared. So please remember, the velocity is measured in meters per second, the acceleration in meters per second squared. Good. So can anyone differentiate the distance so we can find the formula for the velocity, please? Can anyone differentiate, please?
Two t minus 1/2.
Excellent. Can anyone differentiate the velocity to get the acceleration?
Is it
Just
just
P2.
Exactly. And this is, I cannot plug in 1, so this is indeed 2 meters per second squared. But here I can plug in 1. So 2 minus 0.5 is 1.5 meters per second. And one final example. Please do not miss Monday. We're going to review for the test. So, what is this notation? Let's say 29, and I'll stop, I promise. 29, we have y equals x to the 5th, and they want us to find, and I'll read it for you in a minute. They want us to find the 4th derivative of y with respect to x. If you don't like this notation, just write y prime, double prime, triple prime, quadruple. That's all it means. So, can anyone differentiate this for us and give us y prime? Can anyone differentiate this, please? 5 x to the
4th?
Very good. Now we bring down 4. 20 x to the
3rd.
Very good. Now we bring down 3. 60 x to the
2nd.
Very good. And finally 120x. And this is what they want. They wanted us to determine the 4th derivative of this function with respect to x. We differentiate, we find the first, the second, the third, and then the fourth. What if we were asked to find the fifth? What would you say? What would you have said? What is the fifth?
Just 120.
Very good. And what if we were asked to determine the sixth? What would you have said? This way we just added these. How much?
So it'll be,
Exactly. And so will everything else. The seventh, the fourth, the seventh, the eighth, and so on and so forth. This is it. From that moment on, everything is zero. Very good.